Hello, Panthers. It's Mr. Phillips here with you. Let's talk about prime factorization. Okay, so the way that we're going to get prime factorization is we're going to do that with a factor tree. Here's how it works. 24. 24 is not a prime number. What that means is you can break it down into the product of two other numbers to equal 24. So what times what equals 24? Now, using our divisibility rules, we might say, I know that 2 is divisible into 24 because it's even. The question is, 2 times what to give you 24? 2 times 12 is 24. All right. Now, can you break 2 down into a product of two other numbers other than 1 times 2? No, that means 2 is a prime number. So we're going to circle that. 2 is a prime number. 12 is not prime. You could break it down into something times something. So you got to think of what times what equals 12. I'm going to think of 4 times 3. All right, now what about 4? Can we break it down? Yeah, we can break 4 down. Can we break 3 down? No, because it's prime, so we're going to circle that. How do you break down 4? It's 2 times 2. That's prime, and that's prime. All right, so we broke down 24 as much as we could, and the prime numbers are all now in circles. So we're going to put these numbers in order, in numerical order. So we're going to put the 2's in front of the 3. It's going to go 2 times 2 times 2 times 3 is the prime factorization. There you go, that's the prime factorization of 24. And if you were to multiply, you guys can't see that. If you were to multiply 2 times 2 times 2 times 3, that equals 24. So it's the same number, just written as a product of all of its prime factors. Let's try that with 220. All right, so can we break down 220? Yeah, it ends in a 0. If it ends in a 0, that means we could use 10. So it turns out 10 times 22 is 220. Can we break down 10? Yep. 5 times 2 is 10. 5 you cannot break down any further, it's prime. 2 is also prime, but 22 could be broken down. It could be 2 times 11. 2 is prime. Can we break down 11? No, we cannot, so there we go. So all the prime numbers are in circles, that's the prime factorization. Again, we're going to put them in numerical order. We're going to start with the 2's. So it's going to be 2 times 2 times 5 times 11. That's the prime factorization of 220. And if you multiply those all out, it would equal 220. It's just written in a different way. Now we got the same number here, and I wanted to show you this. Let's say the first thing that came to mind for 220 was not 10 times 22. Let's say you thought, well, 220 is even, which means I could use a 2. And the other number would have to be 110. So this one is starting out different than this one. I'm going to show you, though, that even if you start differently, as long as you do it correctly, you'll end in the same place. So 2 is prime, 110 can be broken down. It ends in a 0. That means 5 could go into it. And if you wanted to find out the other number, 5 times what, you could always divide 5 into 110. You could say, what's 110 divided by 5? Turns out it equals 22. So 5 times 22 is 110. 5 is prime. 22 could be broken down to 11 times 2. Those are both prime, and so the answer is 2 times 2 times 5 times 11, which is the same thing that we had this way. So if you do your factor trees correctly, even if you do them different from a different person, you'll still end up with the same answer. Okay, let's try the prime factorization of 102. All right, what number is divisible into 102? All right, well, it's even, right? If it's even, that means it's got to be divisible by 2. And if you're not sure of what the other number is, you could always do 102 divided by 2 to figure out the other number. Turns out it's going to be 51. All right, now I did 51 over here on purpose because a lot of people look at 51 and they can't think of how they're going to break that down, and then they think that they can't break it down. But remember our divisibility rules. Let's check and see what number could work. Okay, 51, is it even? It's not even, so we can't use 2. Does it end in a 5 or a 0? Doesn't end in a 5 or a 0, so we can't use 5. Does it end in a 0? Then we could use 10. It doesn't end in a 0. Now, there's a rule where you have to add up the 5 and the 1. What's the rule that says you're supposed to add up the 2 digits? 5 plus 1 is 6. That's the rule for 3. So, if you do 5 plus 1 and you get 6, does 3 divide into 6? Yes. And you guys couldn't see that. There it is. So I did 5 plus 1 is 6. 3 goes into 6. That means 3 goes into 51. So we could use 3. And again, that's that divisibility rule that we learned earlier. The question is, what's the other number? 3 times what? And again, you can do 51 divided by 3 to figure out that other number. Turns out it's going to be 17. 3 is prime. What about 17? Can you break it down? Well, is it even? Nope, 2 doesn't work. Does it end in a 5 or a 0? No. Let's use that rule we tried over here with like the 5 plus 1. What about if you did 1 plus 7? What does that equal? 8. Does 3 go into 8? Nope, so 3 is not going to work. Does 9 work for it? Nope. Nothing works because it's prime, so we're just going to stop there. So the answer for this one is going to be 2 times 3 times 17. That's the prime factorization. All right, let's try the prime factorization of just a few more numbers. Let's try the prime factorization of 13. Okay, so for 13, I'm trying to break it down. Does 2 work with 13? No, because it's not even. Does 3 work? Nope, 13 is not a multiple of 3. What about 4? What about 5? What about 6? 7? 8? Anything? If the only way that you could break it down is with the 1 times itself, that means it's already a prime number. So this cannot be broken down at all. 13 is a prime number. 21 is not a prime number though. It can be broken down. With what number? 3 times 7 is 21. Can you break down 3? Nope, it's prime. Can you break down 7? It's also prime, so the answer is 3 times 7. That is the prime factorization for 21. There's a couple of different ways you can break down 72. First of all, it's even. That means you can break it down with a 2. When I see 72, what comes to my mind is that 9 times 8 is 72. You can break down 9 and you can break down 8. 9 could be 3 times 3, and they're both prime. 8 could be 2 times 4. This is prime, but this is not. 4 is 2 times 2. So now remember, you want to put the answer in numerical order. So we're going to start, instead of the 3's, start with the 2's. 2 times 2 times 2 times 3 times 3. All right, 37. Can you break it down? Will the 2 work? No. 3? 4 doesn't work. 5 doesn't work. And so after you've used all the rules and you've checked everything, if the only way you could get to break it down is 1 times itself, that means it's already a prime number. And so you can't really do the prime factorization for it. Okay, so there's a little practice with using factor trees to find prime factorization. We're going to use prime factorization to help us with least common multiple and greatest common factor, which are coming up in the future lessons. All right, take care and see you next time.